Do you know how an electric generator works? Electric generator converts mechanical energy to electrical energy. An electric generator, as shown, consists of a rotating rectangular coil ABCD placed between the two poles of the permanent magnets. The two ends of this coil are connected to the two rings R1 and R2. The inner side of these rings are insulated. The two conducting stationary brushes B1 and B2 are kept pressed separately on the rings R1 and R2 respectively. The two rings R1 and R2 are internally attached to an axle. The axle may be mechanically rotated from outside to rotate the coil inside the magnetic field. Outer ends of the two brushes are connected to a bulb to show the flow of current in the given external circuit. When the axle attached to the two rings is rotated such that the arm AB moves up in the magnetic field, the induced current direction can be found by applying Fleming's right-hand rule. The induced currents are set up in these arms along the directions AB and CD. Thus, an induced current flows in the direction A, B, C, D. If there are larger numbers of turns in the coil, the current generated in each turn adds up to give a large current through the coil. This means that the current in the external circuit flows from B2 to B1. After half a rotation, arm CD starts moving up and AB moving down. As a result, the directions of the induced currents in both the arms change, giving rise to the net induced current in the direction D, C, B, A. The current in the external circuit now flows from B1 to B2. Thus, after every half rotation, the polarity of the current in the respective arms changes. Such a current, which changes direction after equal intervals of time, is called an alternating current, abbreviated as AC. This device is called an AC generator.